All right, so we're going to start lesson 2. I have passed out a handout to my face-to-face class that gives sort of an outline of what we're going to go through in lesson 2. Don't ask me why I do this for lesson 2 and not any other lesson. It just seemed like a good idea for some reason. I will post that on the same webpage where I post the link to this video. So if you're online, you should have access to that handout as well. I mean, not if you're online now, but if you're online listening to the recording. Okay, so lesson 2 is about pointers. And basically the philosophy I have about teaching about pointers is all through an introductory programming class and up to this point in this class, I've tried as much as possible to just pretend they don't exist. Okay? And then now it's kind of like I'm going to pull the curtain back and we're going to learn all about pointers, and you'll be experts. It's kind of it's a topic that you have to be very, very careful to get right, or you can get yourself in a lot of trouble. So that's one of the reasons we kind of put it off as long as we can. But we're kind of at that point now where we're going to have to deal with it. So a pointer is simply a variable that stores a memory address instead of storing actual data. And it stores the memory address of some other location in memory that actually does contain the data that you're interested in. Okay? So even though we've tried to shield you from that as much as possible, I have, there's still 3 ways I can think of where you've actually sort of used pointers and we've just kind of not said anything about it. Okay? The first of those ways is when you did pass by reference. Right? So in pass by reference, that's what's going on, right? Instead of actually passing the data, you're passing the memory address of the data. Technically in C++, there's a minor syntactic difference between, that's not actually called a pointer, it's called a reference, and there's a little difference between it, but it's the same idea, right? You're passing a memory address of some of the data instead of passing the data itself. Okay? So the second way that you've already been using pointers is that it turns out in C++ that pointers and arrays are really the same thing. Okay, that shouldn't make any sense at all right now. It'll make sense hopefully by the end of lesson 2. Okay, but this has to do with the fact that, remember when you pass arrays as parameters, what's different about it? You put square brackets, right? That's completely right. It just wasn't what I was thinking, yeah? It's always automatically passed by reference, right? That's because an array name is actually a pointer. And it's just a pointer to the first element of the array. Okay?
I have a question before you
Sure.
go forward. You know how on the previous object that we were doing on the
The integers, yeah.
You mentioned that we were using the address operator, and why when we were using the members of the address operator, we were not using the dash, the dash and the greater than sign to access the members?
Okay. I'll answer that question in just a second, and I'll repeat it. That actually has to do with my third example of how you've seen pointers already. The third example of how you've actually used pointers and haven't really realized it is when we did star this in the feed instance object. I said star this is a way to refer to the calling object. So this by itself is actually a pointer to the calling object. And so star this is the way that you say, I'm not interested in the pointer itself, I want what the pointer is pointing at. Okay? We'll talk about that more. It's called dereferencing. Okay? So I'm not going to go into that in a lot more detail right now. But the question was, hold on, let me get share entire desktop. So a lot of the interface here on CC Confer has changed. So you'll have to bear with me while I try to get used to this. Okay, so here's Visual Studio. And I'm actually okay with how that looks. Okay, so actually I don't want this. I'm going to remove that from the project, and I'm going to get a new source file up here. And surprisingly, I'm going to call it 2. Okay, so the question was, when we were doing the feed instance object, I had star this. Why didn't we refer to the data members of the calling object? We just referred to the entire calling object. I think that was what the question was, right? So
so you know how when we were let me see, go back to the notes. Let's say on the product operator, you are passing the left and the right objects by the address operator, and if that is a pointer, why are we using the dash and the greater than sign?
In the plus operator?
Yes.
And when I say left.feed and right.feed?
Yeah. Let's say when you try to access the members of the object, you're using the dot operator.
Right, like left.feed and right.feed, is that what you mean?
Yeah.
So the question is, in lesson 1, when I did the plus operator, why did I say things like right.feed and left.feed, as opposed to saying what, star this?
No, you know how
left, you mean this?
Yeah.
Okay. Because this notation here means, you know what, actually, can I hold off on that? Because we're going to cover that soon, and I think you'll get it when we cover it. But basically, the dot operator says start with an object and select one component of that object. That's what the dot operator does, so there's no necessity for anything more complicated. I kind of know what you're thinking. We'll get to it. Okay? All right, any other questions before we go on? This is the boring part, right? I'm just talking for a while, and we haven't started doing any code yet. And I also realized that you guys have been sitting here for 45 minutes now, so we'll take a break in a few minutes. Let me just finish up the boring part. All right, so those are the 3 ways that you've already seen pointers, sort of, kind of. So how are pointers used? What are they useful for? I think probably, at least as far as I can tell, probably the most important use of pointers is going to be when we talk about linked structures. So right now, the only way we know to store large amounts of data is in an array, right? Arrays have some disadvantages. For example, you have to decide when you write the kind of array we were talking about so far, you have to decide when you write the program how big the array is going to be, right? So if you have no idea how much data there's going to be, you might have to reserve, 100,000 size array, even if you're only going to need like 3 or 4. That's not likely, but it's possible, right? So a linked list is a way that you store each data piece of data in a separate location, and you just have pointers that go along pointing to the different data, so you can store it all that way. And that way, you don't waste any memory. Just while the program is running, you say, okay, create me another memory location and make a pointer point to it. Okay? That may or may not make sense at this point. Certainly by the end of the semester, that will make sense because we're going to be doing a ton of that. Yes?
Are you told ahead of time which addresses are legal places to store stuff so you know not to go?
No, actually, so the question is, are you told in advance which memory locations are legal places for you to use? The answer is no, the compiler takes care of all of that anyway. You don't get to choose which memory location. So you just say to the runtime environment, I need another piece of memory, and the runtime environment finds one and gives it to you. Okay. All right. So that's a big use of pointers. Another use of pointers is we're going to learn how to create arrays that are dynamic. Which means that instead of deciding how big the array is when you write the program, you get to decide how big the array is as the program is running. Okay? That's an advantage, but it's still not the same as a linked data structure where it can grow and shrink while the program is running. A dynamic array, you create it, and then it stays the same size permanently. Okay, so we'll talk about that. And then a third application that we're going to see a lot of is using C strings. A C string, you know, in C++ we have this nice thing called a string, and we can declare variables of type string if we #include string at the top of our file. And that's a great feature. It's only been around in wide use since the late 90s. Before that, we just used something called a C string, which is much, much harder to use, and you have to be much more careful using it. Sometimes you may still see it used just if in a situation where you really need to be as efficient as possible, and you don't want to go. If you use the string class, it may be slightly less complicated. But anyway, so C strings, and actually C strings are very closely related to dynamic arrays. It's almost the same thing, but a C string has a null character someplace in the array, so that you know where the end of the string is. Okay. I'm going to go ahead and give you guys 10 minutes, and we'll be back at 9:30. And I'm trying to figure out how to pause recording. There we go. Maybe, I don't know. I have no idea whether I... Hold on.
It says recording.
Where does it say that?
Oh, it's the yellow box at the top.
It says you're recording, but if I hit pause, it doesn't do anything.
Oh, that's the share screen thing.
I have no idea what that is.
You just check recording.
Under Tools. Oh, sorry. Try that again.
It's Firefox.
Firefox. Why am I in Firefox now? Jeez.
That's the recorder.
I tried Recorder, but
Recording?
recording. Oh. Ah. Oh, usually it says recording started. All right. So just one more quick thing I wanted to say before we dive in and I show you some stuff. Oh, you want to be able to see what I'm doing? No. You know, I'm just hoping that we're recording. I did hit record. But in the old version there was, yeah, okay. Someone knows. There was a place I could easily just look and see that it was recording. Anyway, yes, thank you. All right. So one more quick thing before we dive in and I show you some stuff with pointers. I just want to say that pointers. It's recording the screen. Appears to pause now. I haven't moved it. Like, oh yeah, it's not. Oh, maybe I'm not sharing. Not sharing. Yeah, I'm not. I don't like sharing. Thank you. There we go. Thank you, Sergi. Okay. So the deal with pointers is that there's going to be a lot of just like detailed stuff that I need to sit here and tell you about before we can really do much fun with them. And so it's not really my favorite type of topic to talk about, but that's what's going to happen. So I'm just telling you up front so you can bear with me and get through this, you know, this part of it, and then we'll do some interesting stuff with what you've got. Sometimes students learn better when there's like something, you know, concrete that you're working on, and they don't learn very well if it seems really abstract and you have no idea how it's going to be used. So you might have to just kind of bear with me on this one and try to stay with me and just take my word for it that it's going to be really useful down the road, okay? I know because I happen to be one of those types of students. All right, here's a statement that declares a variable of type pointer to int. Okay? Now, when you declare a pointer, you can't just say this is a pointer. You have to say what kind of variable it points at. Okay, so that's one interesting thing about C++. You can't have something that's a pointer to an int point to a string or a car. Okay, all pointers can only point at one type of variable. So the asterisk in this declaration statement can go either next to the type like I have it, or it can go next to the variable. However, there's a strong argument for actually placing it next to the variable name instead of what you see here in the example. So think about if we wanted to declare two pointer variables, int pointer and int pointer 1. What do you suppose I have declared there? Well, I've got two variables. What are the types of the two variables? So what I have here is a pointer to an integer and an integer. Okay. So when the compiler looks at this, it only connects the asterisk with the first one. Okay. So that's a pretty good reason, I think, anyway, to put the asterisk, attach it to the name of the variable so that that's clearer. Not that I would want to do both of these on one line anyway, but okay, so now I have two pointer variables. Oh, and I forgot that I actually do quite a bit of drawing in this lesson. And I've never recorded this lesson before, so I've always just used the whiteboard. What I'm going to do is paint. Yeah, everyone's excited about that. Okay, so I wonder if there's some way to get both of these on the screen at the same time. We'll see. So I've declared 2 pointers there, and I want to draw a picture of what that looks like, even though, yes?
If you take it and push it off the side and put the other one to the other side, it perfectly works.
Right.
Did you stop the screen sharing right now?
No, it's still sharing. Yeah. All right, I'm just going to go with this. That's a good advice, but I feel more comfortable doing it this way because I've done it before. So I need a couple of memory locations. So let's do. Let's pick 1, 2, and I need some text because the name of this variable is int pointer, and the name of this variable is int pointer 1. Okay, and what's inside these right now? Garbage, right? Just like any other C++ variable when you first declare it. Garbage. Okay? All right, so, yeah, this is going to be kind of a pain because I'm going to have to. Oh, look at that. But I want this one bigger. Okay, that might work. Okay. Now what I want to do is I want to create an int variable and make int pointer point to it. Okay, let me draw a picture of that before I even show you the code. What I want now is I want this variable down here to be of type int, and I want int pointer to point to it. Okay? So in my code, I'm going to say int I, and then int pointer gets ampersand I. The ampersand there is the address of operator. So I could read this, I could say int pointer gets the address of I. Okay, so that's just another way of saying int pointer points to I. Everyone clear on that? That's like basically that's the fundamental, most important thing to understand about pointers before anything else will make sense. When I say int pointer gets assigned the address of I, that's the same thing as saying int pointer points to I. Okay, and the way we draw that is like this. Okay, because it would be a real pain to have to actually deal with the memory addresses themselves, right? And it's going to be different every time you run the program too. So, just to make this really super concrete for a second, what I could do is I could say, okay, this right here is an int variable. Oh, I forgot to put the name of the variable. The name of the variable is I. Okay, and this variable I happen to know is stored at memory address 5A4E. Okay, now, when we're really talking about pointers, we're never going to actually talk about specific memory addresses like that. I'm just doing this to try to make it concrete. So basically what we're saying when I say int pointer gets the address of I is I'm saying int pointer gets, and then I will put the 5A4E right here in int pointer, right? Yes?
About things said before, I know we're not going to know what the address is here, but is that possible to do in C++?
It's not possible to actually know what the specific memory addresses are, no. Because it'll be different depending on where you run it from and when you run it and what else is running at the time. And okay, that makes sense to everybody about the memory address? And so what's really going on, inside the computer, there's not like little boxes with arrows pointing from one to the other, right? That's not what it looks like in the computer. What it looks like in the computer is there's a little box with a memory address in it. Okay? But programmers never talk about the memory address itself. They just draw arrows. And that's what we're going to be doing a lot of. Yeah, I hadn't thought about it. This is going to be a challenge because you don't have to do that much drawing in an introductory computer science class. But in here, I'm going to be doing a lot of drawing. So I may need to get myself up to speed on it, more advanced drawing program. Yes?
Suggest something. So would it may also help if, as you run the programs, you debug the program? That way you can actually show how each pointer variable.
Oh, I see. Yeah, remind me to do that when we get there. Yeah. We'll probably look at that. Okay. Let me see what's next. Okay. So our next thing that I want to do is I want to assign to I the value 47. How do you suppose I would do that? The easy way. Okay, I get 47. All right, I'm glad everyone knew the answer to that. Okay. So my question is, can we do that indirectly? In other words, can we do that without actually using the variable I, but only using the variable int pointer? The answer obviously is yes. And in order to do that, we would use the dereference operator. Okay, so what this means, this is dereferencing int pointer. In other words, so dereferencing just means if you've got a pointer pointing at something, if I dereference it, it means give me the data that it's pointing at. Okay, or another way to say that is the asterisk there means follow the pointer. This is just another way of saying the same thing. Yeah.
Would you want the I to be 47?
Oh, sorry. I meant, yeah, thank you. Yes, I meant to say 47 then. So, star in pointer gets 47 means put 47 in the memory location that int pointer is pointing at, right? Everyone understand the difference between that and if I just said that? If I just said that, that would mean put a 47 up here in the pointer, right? Okay. So let me add a cout statement to my code so that I have some output to look at. Oops, I think I did that wrong. Yeah. Okay, that makes sense what I'm doing there. I'm just going to print out the value of int pointer, the value of I, the value of star int pointer. What's that? What are we expecting that to look like? So when I print this out, it's going to be what? Some sort of memory address, some sort of hexadecimal? Yeah, hexadecimal number. And then that's going to be 47, and that's going to be 47. So there's my memory address, in case you really wanted to know what, where I was being stored. And 4747. Any questions about any of that? Yeah.
So that memory address will change each time you're in the program?
Well, it could. Yeah. Okay, and now someone suggested that we use the debugger to look at that, and I think that's actually kind of a good idea because it might, you guys are probably at some point, if you haven't already, you're probably going to want to be using a debugger by the end of the semester because things are going to get, you're going to be getting some pretty messy errors that that are going to be hard to track down, and the debugger is going to come in handy. Well, maybe we'll do that next time.
You need a breakpoint omitted.
Oh, okay. I guess I've never, I'm used to actually debugging when I wanted to debug, so I just naturally put a breakpoint in. Okay, so this shows us that at this point in the program, the address of I is that, and you can actually, in Visual C++ anyway, you can actually hover over the variable to see what it's equal to. So int pointer is a pointer, so that's just showing that's a memory address, and it hasn't been assigned yet, so it's just garbage. And if I look inside it, the expression cannot be evaluated. That's because it's an uninitialized pointer. And C++ won't try to follow an uninitialized pointer. Actually, it will try that, but it'll crash. Okay. Okay, and but see if I hover over the I can see that I actually has a value in there. Just nothing. It's just garbage, right? So now if these three buttons up here are the most important buttons in a debugger. This means step. So these two are the same if I'm at a function call. If I'm not at a function call, and then this one means finish up the current function, step out. So I'm going to just use step into to execute that statement. So watch the value of int pointer. See down here right now, int pointer is this uninitialized pointer. When I step it, it's going to get assigned the address of I, right? So this 003 whatever. So there we have the address of I. Okay? And if I click on this, that shows me the exact same thing as the I is showing me, right? Okay? I think I'm going to, I'll go one more step. Okay, I'll go two more steps. No, one more step. Okay, so now I can see that star in pointer is one way of accessing that memory location. I is another way of accessing that memory location, right? Any questions about that? Okay. All right. I did draw a picture of that. Never mind. Okay, I want to talk a little bit about pointers to objects. So just like pointers can point at the primitive types like int and float, they can point at objects, whether they're for a class you've created or for a C++ class. So I'm going to work with pointers to feet inches objects, and so that's why I've included feetinches.h up here, and hopefully I have everything set up correctly so that'll work. So let me you know what? I jumped ahead. Never mind. I don't want to do that quite yet. Okay, so I want to talk about assignment of pointers. That's what I skipped. So below this CL statement down here, I'm going to say int pointer 1. I haven't assigned it to anything yet, right? Int pointer 1 gets int pointer. Okay, so looking at this picture over here, what effect do you suppose that is going to have? So it's going to point at the same thing that int pointer is pointing at, right? So when you see an assignment operator of pointers, I think the most intuitive way to think about it is to just say the assignment operator makes one pointer point to the same thing the other one does. Okay, so in this case, the assignment operator makes int pointer 1 point at the same thing that int pointer points to. Okay. What's really going on, of course, is that I'm just copying the memory address, right? I'm taking whatever is stored in int pointer, which is the memory address of I, and storing it into int pointer 1. Okay, but we don't usually think about it that way. The way we think about it is, I assigned int pointer to int pointer 1. That means and I should erase those question marks too. Okay? There's an eraser. Oh, there we go. All right. Okay, so that's the part I skipped. Any questions about pointer assignment, assigning one pointer to another one? Okay. This is actually, when I look at this picture, I have to say that I cringe a little bit. Okay. The thing that's a little scary about this is that I now have two pointers pointing at the same thing, which can often, if you're not careful and you don't realize it's happening, it can lead to weird stuff. Like, so right now, if I change star int pointer, and I go check out what the value of star int pointer 1 is, it's going to have changed, right? That makes sense? So anyway, that was just a little aside, but it's something that we'll be seeing a lot of as we go on. Okay, now I get to talk about pointers to objects. I'm going to assume that we have that our feed instance objects class from lesson 1, and that there's a print member function in the class. And let's take a look at some code here. Whoops. Okay. Let's draw a picture of what we just did in our code. So am I done with this one, or am I going to come back to that? I think I'm done with that. Okay, bear with me for a second here. Let's. How do I change the color? Oh, change the color to white. No. Oh, and then make it fill. No fill. Solid color. There. Now I want to go back to black again. All right. Okay, so let's draw a picture of what's going on here. I have a feet inches object. I have a pointer to a feet inches object. So here's F pointer 1. Okay, and right now what's in there? After the first statement here, what's in here? Garbage. Okay, then I'm declaring a feet inches object, so down here I'm going to have, oops, that's not what I meant. I'm going to have a feet inches object, and I'm going to make it, a feet inches objects have 2 parts, right? So let me go like this. And I put 7 feet 3 inches, so that's going to be like a 7 here and a 3 here. Okay, so that's the feet part and that's the inches part. And the name of this variable is F1. Okay? Everyone okay with that being the picture after I finish the first 2 lines? Okay? Third line, F pointer 1 gets the address of F1. So that just means make F pointer 1 point to F1. Okay? And then star F pointer 1 dot print. My intention there is that it's going to print 7 feet 3 inches, right? Okay, let's take a look and see if that happens. Okay, I got a syntax error. The syntax error says left, whatever's to the left of dot print must be a class object. Must have class struct union type is feet inches. Does that make sense? The thing to the left of a dot has to be an object. Okay? But wait, F pointer 1 is an object, right? Okay. Well, that's true. F pointer 1 is an object. So why? Oh, I'm sorry. No, F pointer 1 is not an object. Star F pointer 1 is an object, right? Sorry, I said that totally wrong. Right? Star F pointer 1 is an object. So what's the problem with the dot there? Okay.
The dot, it sees the dot first, and then applies the star to the whole thing.
Okay, it sees the dot first and then applies the star to the whole thing. What's that called? The decision about which one goes first? Operator precedence, right? So dot operator has a higher precedence than the star. Okay, so how do we get it to do what it is we want it to do? We use parentheses in an expression to force operations to be executed in a particular order, right? So will that work? Let's give it a try. There we go, 7 feet 3 inches. Okay? Now, oh, that was the wrong side. This is really an inconvenient notation. And in our programming later on, we're probably going to run into situations where we're following chains of pointers. So we're going to we'd have like all these nested parentheses, and it really gets kind of ugly. So C++ provides a special operator that is, this probably isn't what it's actually called, but I call it the dereference and then select operator. Okay? Basically, it just combines two operations into one because we want it to dereference and then select. So the way that's going to look is arrow. And the way that I pronounce that is arrow. So I will say f_1 arrow print. Well, and so I'm sitting up here thinking, I wonder if that's really the right way to pronounce it. I've always pronounced it that way for 30 years. I must have learned it somewhere from somebody, but I have no idea where from. All right, any questions about that? That arrow means dereference and then select. So you'll get used to it. It's just a way of saying, take what this is pointing at and give me one particular component or one particular member of that object. Okay? So you're only going to use that notation when you're working with objects, right? Because it doesn't make sense to select something if it's not an object to start with. Okay, any questions? Okay. All right, now I want to talk about arrays of pointers. And just to make things even more interesting, I'm going to make it an array of pointers to feet inches objects. So I'm first going to declare 2 more feet inches objects and 2 more pointers to those feet inches objects. So I'm going to make this 2, 3. Okay, I guess I'll just add this below. Star f pointer 2, star f pointer 3, f2, f3, okay. So what does that give me? That gives me something that I don't have enough space to draw. I'm going to have to just overlap these a little bit. Let me draw f pointer 2. And f pointer 3. And f2, which is 4 feet 7 inches, and f3, which I can't see, 9 feet 2 inches, okay? And this one gets split in half. Because those are feet inches objects, okay? So now I have, let me put the names on these. See, this is f pointer 2. This is f pointer 3. This is f2. This is f3. And this is 4, 7. And this is 9, 2. Okay, all of this is just to set up things so that I'm ready to do my array in a minute here. So the next line of code is I'm going to say f pointer 2 gets the address of f2, and f pointer 3 gets the address of f3. So what that does is it gives me the arrows, right? All right, everyone with me so far? Everyone able to look at these three statements right here and see why they gave me those pictures? No questions? Okay, then let's declare an array. Oops. Okay, so let me draw a picture of that. Get that in your brain because I'm going to have to cover it up while I draw the picture. Okay. So I'm declaring an array with 10 pointers in it, right? The star right here, after the feet inches, says this is not an array of feet inches objects. It's an array of pointers to feet inches objects. So it's got 10 elements. Zero, 1, 2, 3, and so on. That's about 10. 0, 1, 2, 3, and so on. Okay? And the name of this array is array. Okay? That's my declaration. But I also did some initialization, right? I said I assigned values to the first three elements of the array. So the first element of the array is going to point to the same thing that f pointer 1 points at. And f pointer 1 points here, right? So it's going to point here. And this array sub 1 points to the same thing that f pointer 2 points at. And array sub 2 points to the same thing that f pointer 3 points at. Everyone okay with that? Any questions? Fun picture, huh? Yes?
Instead of writing the pointers, you just use the address.
I could use ampersand F1, ampersand F2, yeah. Yep. It's actually pretty rare in programs that I've seen or worked with to use the address of operator very much. So I'd rather illustrate it this way. So just for fun, let's do an assignment. Let's say star array sub 0 gets star array 1 plus star array 2. Yeah, I knew that was going to happen. Okay? What is that going to do? Go ahead.
Just bring together and store it as F1.
Right. This is basically this is the same thing as saying F1 gets F2 plus F3, right? The thing that array sub 0 is pointing at, assign that the sum of the thing that array sub 1 is pointing at and the thing that array sub 2 is pointing at. Okay? That star operator there is why I say the thing that blank is pointing at, right? For some reason, all of a sudden I got lots of blank stares. So if anyone has a question, tell me now, or everyone just knows it's 5 minutes to the end of the class, and if I can just make it 5 more minutes, I'm out of here. Okay. And I'll just go watch the recording, right? Okay. So let me just make sure about that with a cout statement. Array sub 0 print cout indel array sub 1 print cout indel array sub 2 print cout indel. So we try this? Oh yeah, that's not what I meant. I meant to say no. What did I mess up?
The array needs to be declared before.
Oh, I never declared my array.
It's just below.
Oh.
Just typed it all above it.
Oh, I typed it all above the array? Thank you. Oops. All right. Let's try that again. Okay, so I probably should have said a little more so we could identify what's happening here, but I'm printing array sub 0 arrow print. That's the 13 feet 9 inches because I added 4 feet 7 inches and 9 feet 2 inches together. So that's where the 13 feet 9 inches comes from. Okay. All right. I will. Between now and Wednesday, make sure that you take a close look. You can't because I'm not going to have posted the lecture notes. Never mind. Although you could go look at the recording probably. If you guys here could just hold on for just a sec after I figure out how to log off or stop recording, I mean.